There is no 100-foot rule explicitly stated in the National Electrical Code regarding conduit bending. The code stipulates that there shall not be more than the equivalent of 4/4 bends, totaling 360 degrees, between pull points. These pull points can be conduit bodies, junction boxes, pull boxes, handholds, or other accessible locations where wires can be pulled through. This 360-degree limit applies irrespective of the length of the conduit run. In practice, the 100-foot rule is a general guideline electricians often use. This rule suggests limiting the total bend angle to 360 degrees within a 100-foot run. It's a practical approach to prevent excessively long or difficult wire pulls, but it's not a mandatory code requirement. Situations may arise where longer conduit runs with more bends become necessary or acceptable, depending on various factors. Factors influencing the number of bends and the length of conduit runs include, firstly, the size and type of conduit. Larger conduits generally allow for easier wire pulling, potentially accommodating more bends or longer runs. Secondly, the number and size of conductors are critical. A higher number of conductors or larger conductors increase friction, making it harder to pull wires through multiple bends or long distances. Thirdly, the presence of obstacles needs consideration. Obstacles in the building structure might necessitate more bends to navigate around them. Fourthly, accessibility for pulling wires plays a vital role. Easily accessible pull points simplify wire pulling and may justify longer runs with more bends. Fifthly, aesthetic considerations can also influence conduit layout. While functionality is paramount, maintaining a visually appealing installation is often desirable. It's important to carefully consider all these factors and plan conduit runs accordingly. The aim is to ensure an installation that complies with the electrical code and remains practical for wire pulling and future maintenance. The equivalent of 4/4 bends refers to bends each having an angle of 90 degrees. If multiple bends are necessary within a shorter distance, consider using elbow fittings or sweeping bends. These fittings minimize friction and facilitate easier wire pulling. Always consult the latest edition of the National Electrical Code and local amendments for specific requirements and interpretations. Understanding the code and applying best practices are crucial for safe and efficient electrical installations. Remember that exceeding the 360-degree limit increases the pulling force required, potentially damaging conductors or making installation impossible. Proper planning and execution of conduit runs are essential skills for any electrician. This includes selecting the appropriate conduit size, minimizing the number of bends, and using proper pulling techniques. The NEC provides guidelines in Chapter 9, Table 1 for conduit fill, which is the percentage of the conduit's cross-sectional area that can be occupied by conductors. Adhering to these fill limits ensures adequate space for heat dissipation and prevents damage to conductors during pulling. When making bends, use the correct bending equipment and techniques to avoid damaging the conduit. Kinks or flattened areas in the conduit significantly increase friction and can make wire pulling extremely difficult. Before pulling wires, always lubricate them with an approved wire pulling compound. This reduces friction and makes the pulling process smoother and easier. For long or complex conduit runs, consider using intermediate pull points. These pull points break up the run into shorter segments, reducing the pulling force required. When installing conduit in wet locations, use watertight fittings and seals to prevent water from entering the conduit. Water can damage conductors and create a safety hazard. Always properly support the conduit to prevent sagging or movement. Use appropriate hangers and straps spaced according to the NEC requirements. When grounding and bonding the conduit system, follow the NEC guidelines to ensure a safe and effective ground fault path. This is crucial for protecting people and equipment from electrical shock. Always double-check your work to ensure that all connections are tight and that the installation complies with all applicable codes and standards. A thorough inspection can identify potential problems and prevent future issues. In summary, while the 100-foot rule is not a formal requirement in the NEC, it serves as a helpful guideline for planning conduit runs. The key is to understand the factors that influence wire pulling and to design installations that are both code compliant and practical. Always prioritize safety and follow best practices when working with electrical systems. Remember that electrical work can be dangerous, and it's essential to have the proper training and experience before undertaking any installation. If you're unsure about any aspect of the work, consult with a qualified electrician or electrical inspector. Furthermore, it is important to understand the concept of directing conductors when multiple current-carrying conductors are installed in the same conduit. The NEC specifies directing factors to reduce the ampacity of conductors based on the number of conductors and the ambient temperature. This directing is necessary to prevent overheating of the conductors, which can lead to insulation failure and potentially cause a fire. When calculating the required conduit size, consider the directed ampacity of the conductors and ensure that the conduit is large enough to accommodate the conductors and allow for proper heat dissipation. The NEC provides tables that specify the allowable ampacity of conductors based on their size, insulation type, and temperature rating. These tables are essential for determining the correct conductor size for a given application. In addition to conduit fill and conductor directing, it's also important to consider the voltage drop in long conduit runs. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to a certain percentage of the supply voltage. To minimize voltage drop, use larger conductors or run multiple conductors in parallel. When selecting conductors for a specific application, consider the environmental conditions to which the conductors will be exposed. Conductors are available with different insulation types that are suitable for various environments, such as wet locations, high-temperature environments, and corrosive environments. Choose conductors with insulation that is appropriate for the intended application to ensure long-term reliability. When terminating conductors, use the correct types of connectors and follow the manufacturer's instructions. Proper terminations are essential for ensuring a secure and reliable electrical connection. Loose or properly installed terminations can cause overheating, arcing, and even fires. Always use a torque wrench to tighten connections to the specified torque value. Over-tightening or under-tightening connections can damage the conductors or connectors. When working with aluminum conductors, use connectors and terminals that are specifically designed for use with aluminum. Aluminum conductors expand and contract more than copper conductors, and using the wrong types of connectors can lead to loose connections and overheating. Apply an oxide-inhibiting compound to aluminum conductors before making connections to prevent corrosion. Corrosion can increase the resistance of the connection and cause overheating. When installing conduit in concrete, use expansion fittings to allow for movement of the concrete due to temperature changes. Concrete expands and contracts with temperature changes, and if the conduit is rigidly embedded in the concrete, it can crack or break. Expansion fittings provide a flexible connection that allows for movement of the concrete without damaging the conduit. When installing conduit underground, use conduit that is specifically designed for underground use. Underground conduit is typically made of PVC or fiberglass and is resistant to corrosion and moisture. Bury the conduit at the correct depth to protect it from damage. The NEC specifies the minimum burial depth for different types of conduit. When crossing underground utilities, maintain the required clearance distances. The NEC specifies the minimum clearance distances between underground utilities to prevent damage to the utilities. Before digging, always call the local call center to locate underground utilities. This will help prevent damage to the utilities and ensure your safety. When installing conduit in hazardous locations, use conduit and fittings that are approved for use in those locations. Hazardous locations are areas where flammable gases, vapors, or dust may be present. Conduit and fittings for hazardous locations are designed to prevent explosions. Grounding and bonding requirements for electrical systems are covered in Article 250 of the NEC. Grounding and bonding are essential for providing a safe and effective ground fault path. A ground fault is an unintentional connection between a live conductor and ground. If a ground fault occurs, the grounding and bonding system will provide a low impedance path for the fault current to flow back to the source. This will cause the circuit breaker or fuse to trip, interrupting the flow of current and preventing electrical shock. The grounding electrode system is used to connect the electrical system to the earth. The grounding electrode system typically consists of a ground rod, a ground plate, or a metal water pipe. The grounding electrode system provides a path for fault current to flow to the earth. The equipment grounding conductor is used to connect the non-current carrying metal parts of electrical equipment to the grounding system. The equipment grounding conductor provides a path for fault current to flow back to the source. The bonding jumper is used to connect different metal parts of the electrical system together. The bonding jumper ensures that all metal parts of the electrical system are at the same potential. This reduces the risk of electrical shock. The size of the grounding and bonding conductors is determined by the size of the overcurrent protection device. The NEC provides tables that specify the minimum size of grounding and bonding conductors. All electrical equipment must be properly labeled with the manufacturer's name, voltage rating, current rating, and other important information. The labeling must be legible and durable. Electrical equipment must be installed in accordance with the manufacturer's instructions. The manufacturer's instructions provide important information about the installation, operation, and maintenance of the equipment. Always follow the manufacturer's instructions carefully. Electrical equipment must be maintained in good working order. Regular maintenance can help prevent problems and ensure that the equipment operates safely and efficiently. Electrical equipment must be inspected regularly for signs of damage or wear. Any damaged or worn equipment must be repaired or replaced promptly. Only qualified electricians should perform electrical work. Electrical work can be dangerous, and it's essential to have the proper training and experience before undertaking any installation. Always follow safe work practices when working with electrical systems. Wear appropriate personal protective equipment such as safety glasses, gloves, and insulated tools. Energize circuits before working on them. Use a voltage tester to verify that the circuit is de-energized. Lockout and tagout procedures must be followed to prevent accidental energization of circuits. Never work on energized circuits unless it is absolutely necessary. If you must work on an energized circuit, use extreme caution and follow all safety precautions. Never work alone. Always have someone nearby to assist you in case of an emergency. Report any electrical hazards to your supervisor or to the appropriate authorities. Electrical safety is everyone's responsibility. By following safe work practices and adhering to the NEC, you can help prevent electrical accidents and ensure a safe working environment. Always remember to consult the latest edition of the NEC and any applicable local codes or regulations before beginning any electrical work. Staying up to date on the latest codes and standards is crucial for ensuring safe and compliant electrical installations. Consider attending continuing education courses to enhance your knowledge and skills in the electrical field. Continuous learning is essential for staying ahead in a constantly evolving industry. Seek guidance from experienced electricians or electrical inspectors when faced with challenging or unfamiliar situations. Learning from others can provide valuable insights and help you avoid costly mistakes. Prioritize safety above all else when working with electrical systems. Your well-being and the safety of others depend on it. The information provided here is intended for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician or electrical inspector for specific guidance on your electrical projects.